Sort of, yeah, I do right now. Ken, when did you want your photos for your presentation?
No, it's for observing the sun.
Yeah.
It's just a couple of pictures I've taken recently, so no big deal. It's the four that are on there. So if you start at the first one, you can look at it now.
This is a
Yeah, that's right.
Yeah, I'm like,
yeah. I know, expected the opposite. 4 hours for about 30 miles.
So we pretty much, I think we just got a little bit.
It was, yeah. Yeah.
Okay. So if you want to do Good evening, everyone. Welcome to the September meeting of the Royal Astronomical Society of Canada. Chris Peirce, the Centre President. As many of you know, we've had quite a major summer this year, so we hopefully have a few people talking about some of their experiences with the eclipse viewing. Our agenda tonight is we'll start off with an impromptu observing report if anybody wants to say a few words. We'll then have some announcements from your center executive and council members. We'll go over some upcoming events. We'll then have our guest speaker, and for the termination of the night, we can go over to the 4th floor lounge for everybody who wants to join us and have coffee, tea, and cookies in the staff lounge on the 4th floor. So as we did have a very major event, I thought I'd start off today by doing a little poll in the room. So if you just raise your hand, I'd just like to see how many people watched the eclipse from Victoria or somewhere else in Canada. Okay, that's quite a good group. And how many traveled to see it and saw totality? So quite a few people did travel, obviously. We did a couple of outreach events, and I don't know if, let me see if I can switch computers here. And maybe Rich, you can help us. Ken, did you want to show a few photos? Hit switch. Which photo would you like first?
Yeah, that one is fine.
So Ken, our outreach coordinator, has a few photos and comments to make.
This is the first night of the fires, I guess, recently. So I just thought I'd run outside and take a picture of the moon. Looks like it's one of those eclipse moons. So it's just beautiful. Yeah, next one, Reg. Most of you know I have a hydrogen alpha telescope. So I thought I'd start taking pictures with my Canon.
Start getting interesting.
Well, it's a good damage.
Okay, I'll work to my computer.
Okay, let's see here.
Can you open it with something else? Right?
Well, some of these things are CR.
Oh, they're the Canon.
Yeah.
The Canon walls.
Yeah, did you hear that right on the preview? See if that
I don't know the right click.
control. Control click.
Murphy is in the room.
There we are.
So what do you know?
You're in the app. You
You need to be on the photo. So that one, yeah. That one. So hold control and click. And open with preview. Let's see if that works. I was thinking about it.
If it understands wrong.
Hey, look at that. Wow.
Oh my gosh.
That's quite a shot.
So with my Canon, I put it on my hydrogen alpha, and this is one of the first pictures I took. You can see the prominence there. It's not really clear. It's about the middle there.
Look at that
Yeah.
one for that.
It's a big one. Go ahead, the next one there, Rich.
So see the Eclipse. That was just, that wasn't on the Eclipse.
It's the Canon for astronomy, 6DA, I believe it is. So it's a little more pink because it gets more hydrogen alpha than the regular Canon.
See some spots on it.
Yeah, there's some sunspots, yeah. So I'm still not very good at processing them, but just thought I'd share. Okay, that's fine there. Thanks, Rich.
Great.
All right, well, thanks very much, Sharon. I'm sorry about the Eclipse design to open when you've got a raw Canon file.
Okay.
So I was trying to do, so it was
giving.
giving me, but it didn't help out.
Did anybody else have anything they'd like to share? Any of the people who were here? Got to enjoy the eclipse for beautiful Victoria?
Visually.
Yes, well, but you don't tell us about it.
Well, as I was going to say, I've said it before, the most of people deserted last year. We were left a few here to mend for, and we had a wonderful experience here. I was set up in front of the museum. Went there at 7:30, expecting no one there, and already there was a big crowd expecting their solar view glasses. And soon, Jim Stillburn, Michael Wheatley, Leanne, and Prem, and including my granddaughter, she helped me greatly, otherwise I would have been lost. Anyway, we set up, as we were setting up our telescopes, and the crowd was getting agitated because they were not getting their solar view glasses right away. And the things were getting out of control. Out of control in a way that there's going to be a mob riot. So we are going to call 911. Hopefully there will be some help from the local police department. Anyway, out of this mob environment, 4 people from the public came out, and they were quick thinkers. They sensed the predicament we were in. They came in to help. And I have their names, and they haven't thanked individually, but I would like to say something about them, what they did. Ellen Britton, who was a crowd calmer. She's terrific. And soon she will be surprised that she's a new member, our new member. So I bought a membership as a thank you to her. She doesn't know yet, but hopefully she will know pretty soon. And Justin Bolton, he was a telescope operator. Fantastic. He did from 7:30 onward till 11 o'clock. He was there manning this telescope. Otherwise, we would have been lost. And Janet Davies from the museum, she stayed there for the whole period. And Lori knows her. She was a great help. And the last person who helped the crowd control was Lisa Orantes. I'm hoping I'm pronouncing her name correctly. And I think without them, we would not be in good shape. And I really appreciate people who are on their feet, they think right way, they sense the problem, and they found solutions. Yeah. And it was great. Yeah. Overall, the event went quite smoothly, considering the predictions we were in, and everyone had a great time. And we gave away all the solar view glasses. So anyway, thanks for Ken for giving me a little bunch. We could have used more, but anyway, that's the way it goes.
Lessons learned, yeah.
How many people were at the event?
Or at least, I was going to say more than 1,500 people, but because there was too many. I gave the counter to Kira. Say, no, you count. He said, well, she was telling me that I don't want to count double. And I said, well, after about 900, she gave up. I said, okay. Pretty good. Anyway, it was a great time.
Well, thanks to
Please,
the
next time, make sure that when you go to 2024 or go to Chile, consider about
Take you
people
with
who are
us.
still here.
yeah.
Hey, I'd like to that.
Yeah, I think we learned some lessons from that because I think some of the events are getting more and more popular, and the report from Vancouver was they got overwhelmed as well. And so, yeah, we've learned some lessons, I think. And I think the university got overwhelmed as well.
Yeah.
So, yeah, it turned out to be a much more popular event.
High, media height.
Yes.
Yeah.
Joe?
Since no one else stood up that did some traveling, I'll just give you a quick slideshow of RASC members' photographs. People in the audience who took these photographs jump in, they're not all mine by a long shot. This is the, unlike Victoria and Vancouver, Oregon was ready for the deluge of the estimate of 1.5 million people to show up on one particular day. And this was Western Oregon University, their AstroTurf field in Monmouth, Oregon, which is near Salem. And it was very, very close to the center line. And there was about half a dozen of our members there, including myself. So this one I think was taken by John. It's just showing our VP sitting there.
Well, that's John there, isn't it? And that's Reg. I think
That's Reg, I think, there.
standing there, isn't it?
And
John
John,
sitting up
and
there.
that's
And that's you over there.
you on the left. I don't have my pointer with me.
I'm in front, I'm collapsing, I'm crying at this point. I just went to my knees, my knees gave out.
That's me looking up at my binos.
There you go.
Reg, is that you guys?
Yes,
Yeah.
yeah, I was quite, it just kind of struck
So
me.
this is totality on the observing field. We probably had about, what do you say, John, about 500 to 1,000 people on the field?
Yeah,
Maybe 500.
maybe 500.
I don't think 1,000.
It was
Lots of room.
It was lots of nice crowd, but it wasn't overcrowded. It was
No.
nice.
And the university was ready for us, so. John's totality shot showing prominences. And this is a sequence he has built up. And this is the pièce de résistance. The best shot of the eclipse I think anyone has taken of this particular eclipse. How many photos, John?
Pardon me?
How many photos did you combine for this?
Well, it was not only 9, there were really 11 because there were a couple same exposure, 9 different exposures.
Give you prominences and the plasma streamers and the corona all in one was amazing. And
That's my iPhone shot.
there you go.
My hasty iPhone shot from Madras. I think you can see that Venus over there.
Yeah, excellent.
And
It was relatively bright.
yes, I decided, I think I had 4 cameras, 2 operating automatically, both failed. And I budgeted about the first 30 seconds or so to take a couple of pictures with this thing to post.
Yeah.
And I took one with a couple with my cool pics that weren't bad. And meanwhile, my wife Audrey was sitting next to me with a DLSR with a telephoto on it. I have a DLSR but no telephoto, and she took really fabulous photos, much better than anything I took. And we were in Madras. I was with a group, including people like Patrice Stavelin from the Montreal Center, and David Levy, of Shoemaker Levy fame. So it was fun. And that's on the grounds of the Econo Lodge in Madras. And you can see down there's some clouds. There was some smoke not that far away, although it seemed to go away just at the time of the eclipse, and then it kind of came back a little later on. There's probably still some around.
So this is a good sequence showing the filtered views of the moon as we had first contact. So you can see a little notch coming out of the sun there.
Just
Starting. So lots of good detail here. I forget who took these photos. I'm just going to scoot through them in the interest of time. These are mine, which is similar. Not as much detail. I got a thinner. This is another cell phone shot that I took. This is the only successful totality shot that I took. And but that showed Venus.
Yeah.
Oh, okay.
And it
Yeah.
also shows a contrail, which people saw across the whole state here.
They were quite curly, weren't they?
We were kind of mystified by what that contrail was all about.
So is it a reflection off the grid, or is it a balloon?
That's Venus, isn't it? Up
That's
to the upper
Venus.
right? Yeah.
Yeah. And you probably picked up something
Oh,
else.
three.
That's why I took the photograph for it. I zoomed in, so it's not exactly sharp. Jim Cliff's Diamond Ring, beautiful shot. And more crowd shots. I think this is Jim's crowd shot taken about 200 meters from where we were. Another field in Western Oregon University. Did you want to add anything, Jim?
Not really. I was just remarkable. It was remarkable how chilly it got.
Yeah.
Not so much the actual temperature change of the air, but how much radiation was coming in from the sun.
Yeah.
Actually, this and the Diamond Ring are interesting because I had my Canon DSLR set up on the 600 millimeter refractor as well on automatic, and I got a fairly good sequence of the whole coverage and uncovering. But in the moment of totality, I completely forgot to take the filter off.
Oh.
So the sequence goes crescent, black, crescent. So,
Guess who else did that? That's my Eclipse and I screwed up.
so luckily, I also had a old Canon 81 film camera, 35 millimeter, with a 200 millimeter lens, and had that one set up as well, so the 5 or 6 pictures that I did get just from the Canon.
Scan comes to the rest.
This is on 400 ASA Fujifilm.
Great.
Is that a star? Is that Regulus?
Before Stephen O'Hara telling us about what to look for. You should have been there. Diamond ring filtered off.
Yes. Like a filter also off the other.
And David Lee got some great shots from Corvallis, which is sort of halfway southern band of the.
So I was there with two of my friends from the university, which just celebrated their anniversary the day before, and Jim and Betty were there along with their daughters. So Jim and Betty and their daughters were behind us, I believe. Yeah.
lots of excitement on the field.
There was, and I made a lot of mistakes too, but I'll tell you, that's another story. Takes a full story to tell that.
And when you only have 2 minutes, it counts, doesn't it?
This is your field.
This is on the field that we were on. AstroTurf. No, that's not our field, but it's a previous.
Oh, yeah, we were on Astronomical.
I'll have more pictures to show on the Monday night.
Yeah, I just threw this together, so I quite apologize for things being out of sequence. This is Jim again, I believe. Right?
This was actually quite funny because there was a bit of a mix-up over where we were going to go, and that's a different field than the rest of them from RASC. But I brought this umbrella with the flag on it to sort of mark the space. And nobody from Victoria showed up there, but everybody else who'd come down from Canada just sort of. It was the Canadian embassy.
I think these are Audrey shots we're looking at now, and a couple before gyms. There was a couple of little guys, and those were mine with the cool pics.
Okay, great. Yeah, she did well.
There was, no
You see
no
that?
coaching or any discussion, she just took the pictures. Yeah.
Morgan a little bit washed out, sorry.
Oregon State University.
Oh, that was.
And David, the teachers put together a composite.
Yeah, I mean,
That was
this is
so
really
cool.
mainly a memory job for me, because I wanted to remember the main features of the eclipse. So I put this together from my own images. I think what's really neat were the prominences. There's actually a prominence at 12 o'clock, but in my processing it was a little bit aggressive, so you don't see it there. But it's actually denoted by the helmet streamers, like these kind of pointy streamers. So anywhere where you see a helmet streamer, there's typically a prominence underneath of it. So you can see that.
Like the, like the cone shape.
Yeah,
streamers,
they call it a
ones.
helmet streamer.
Okay.
And the thing that was really remarkable was that central string of spots. And of course, there was an emerging set of spots coming up from the limb. So that was, yeah. Well, you can see it right there. It's right in the central. 6 o'clock. You got to see it. And I'm so glad I took the Pronto down with me, because my friend Don did wonderful public outreach while I tried to take pictures. So that was really great. And actually, he even encouraged me to take some views through the telescope. And I thank him for that. This was my attempt at kind of simulating what I actually saw with my eyes. So basically, I took one of the images I had from totality and artificially occulted it. And then I changed the background to blue. And as close as I can think, this is what I saw with my eyes.
Yeah, that's nice.
And this is just before first contact. So I imaged each of the sunspots that day. And some more shots from around us. That's one of my diamond ring shots, and that's totality decided. And one of my partials and totality. And then that's my diamond ring.
Great. That's super.
That's it.
Thanks for putting it together, Joe.
Joe, can I say something about that very last picture?
Sure.
We'll put it back.
I think
These are all available on the Zenfolio imaging site that we post our photographs from.
one of the most remarkable things about being down there for me was that all the information we had ahead of time suggested it was going to be just an unbelievable walk. And it wasn't. It was actually quite lovely. And as Joe said, the Western Oregon people had done a wonderful job of getting ready. They had bags and bags and bags of glasses for anybody that came along who wanted. And it was a really nicely handled event. I think if there's another eclipse, we should have it at Western Oregon.
It was far from apocalyptic.
They had good coffee too.
Yeah, I'd like to make a comment. I've been, thinking a lot about how all that kind of stuff kind of turned out, and I have mixed feelings on it, but I think a lot of people just decided then an eclipse is an eclipse is an eclipse. That they didn't make the distinction that we do.
Yeah.
Which in some ways is sad, but in other ways,
I agree.
thank God. At least for those of us who were down for the totality. But, while I got the floor, I really want to thank all the folks who were up here and dealt with that situation. And, plus our close personal friends in the municipality of Saanich, which I heard about. And I would suggest that we never again hold an astronomy event in Saanich. If all we can think about is charging us rather than helping us. But anyway, the people up here did an amazing job. I heard all these people saying, "Oh, well, it's 90%, it's fine." Or, even in Oregon, I'm watching the news and, well, we're just outside totality, but who cares, That's, I hope somebody does a study on that.
I might add to that, following up on what Chris said, Betty and I were with David and Brenda in Fort Hollis, and they had set up a full 2-day speaker program of talks and art shows that were all aimed at the public. Very, very accessible. And our two daughters, who are not wild about astronomy the way we are, I think they felt and learned a great deal in anticipation of what was going to happen. But one of the speakers, when he was asked, well, yeah, this 90% versus totality, is it really worth it? And his way of looking at it is say, imagine a black and white photograph of a hot fudge sundae. And then imagine eating a hot fudge sundae. and I think something between the photographs, and certainly David's photographs that he showed where he said he was as close as he could get it to what we saw, is just exactly the way we felt and experienced it. But there's nothing that describes the feeling of a total solar eclipse. Until you experience it, you cannot believe how incredibly special it is. And so in 2024, go for the eating the hot fudge sundae. Go to Texas or Mexico or New Brunswick and try to see it. And one last anecdote from the field we were on with David and Brenda. I was just lying on the astroturf watching when it hit fourth contact. Somebody on the field shouted, "Encore!"
And everybody on the field, the 300 or 400 people who were left there, all started applauding and whistling and shrieking in approval of this comment.
We will have some audio through video coming up because a couple of our members, at least in Monmouth, have that in the wings. So there's more excitement left.
I have
On a
a
personal
drama.
note, I just want to thank all the people who were from Victoria and who joined me at in Monmouth because this is my fourth eclipse. The first three I was observing the strangers, although they were very nice people. It's just not the same as having your friends there, and I was tremendously excited. Probably one of the reasons I missed the photographing totality, but I saw it visually for the whole 2 minutes, so I'm not complaining a bit. Thanks.
Last Monday night at Astro Cafe, there was an absolutely amazing set of images and experiences related, and there will be an entirely new set next Monday. If you can possibly go to Astro Cafe next Monday, do so. You will not be disappointed.
Cookies will be provided.
Oh,
yeah, I have some. Right.
Well, thank you, everyone. I think in the interest of time, maybe we'll move on to our announcements section. Not too much to report from me with respect to membership, except that we've reached 264 members.
Wow.
So we do have quite a few people who are in that grace period time, but the membership continues to grow of the center, which is nice. Reg, do you have anything from? Of course, I do.
Speaking of new members, we have Maria and Marcel here. Is there any other new members here tonight? Welcome aboard. The Sky News does feature John's beautiful picture, and there's some talk about the features of coronas inside, as well as an excruciating description of the agonies of the people who were left behind, who had to perform riot control of Victoria in a section devoted to outreach. And thanks for plugging Astro Cafe. Also at Astro Cafe, we're going to be having the unboxing of our new reflecting telescope, and that should be exciting as well. So it'll be a great night there. And that's all for me, thanks. Great.
Reg, did you want some eclipse stories from people for the October issue?
For the October issue, I'll be asking people at the Astro Cafe for that as well. We, the idea is for me not to have to write anything, some other people to write.
You can be a true editor.
Yeah.
We'll just switch them together. And, if anybody's got a story to tell, please let me know, and I'd be delighted to incorporate it into next month's blockbuster Eclipse edition.
Bruce isn't with us this evening, so we don't have a treasurer's report, but there is money in the bank, so we're fine. Ken, do you have anything from outreach?
Yeah, it was, excuse me, I'm the outreach coordinator. Ken, it was a pretty busy summer for us. We had Fort Rod Hill, and I had to call extra astronomers in because I got an email a few days before, and they said, well, it's really taken off. There's probably 200 people there. So when we got there, we set up, and there was probably 300 people there. There was a 10-person line, long line behind each telescope that was there. So it was very good. I got a lot of good responses from that, including the people who organized it through Parks Canada. My version, Sid had his version. My version was Mount Tommy. Dan took this picture just on the inside of the Sky News to show just how many people were up on Mount Tommy. The reservoir was absolutely full. The rock behind the reservoir was absolutely full. There's people in the parking lots, in the lower parking lots, and down around in front of the reservoir. So yeah, I would estimate there's 1,500 people there, probably equal with Sid's. When I first got there, Jennifer was already set up, and there was already a 30-person line around Jennifer waiting for their sunglasses. So when I got there, Jennifer said, oh, there's a person with the glasses. So they all came rushing over to me. And I finally ended up getting a little angry with them, saying, look, we want to give it out our way, not your way. I know you've numbered yourselves, but, so we ended up having to give them to family groups, friend groups. We made them get into groups of 3. So our 100 glasses stretched to about 300 glasses. And they were all given out about an hour before eclipse time started. So it was quite amazing. It was overwhelming. There were so many people there, and I was pulled in so many different directions with interviews, asking questions, running 2 telescopes. Even though my wife was running one, she would often get it out of alignment, and I'd have to run over and fix it. But it was overwhelming, but really good overwhelming. So museum had 1,500, and Sherry out in the Chosen had approximately 500, and I heard up to 800 people out in the Chosen cricket pitch where we had our summer star party. So it was quite a good event that we managed there. Saanich Fair, we had, as Lori reported in her email, we had about 200 people there for the 3 days. Yeah, everybody seemed to enjoy.
2,000?
2,000, yeah, that's what you said, isn't it?
You just said 200.
I'm sorry, I got the 2 right. 2,000, yes, about 2,000 people for the 3-day event. It was really good. I was watching TV tonight, and Nova on PBS. I don't know if you get Telus or Shaw. PBS, it's Dive into Saturn, Cassini's last. So if you want to go home and tape it on PBS, get your PVR running, it should be good.
The event will be happening Thursday, Friday, though.
Yes, but this is just what Cassini has done so far. I have an outreach event for a seniors home. I already have 1 volunteer, and David's volunteered to give us a speaker, but I could use a couple more volunteers to show the seniors The Sky, it's on October 5th, Thursday night, and we'll be showing from 9 to 11 outdoor viewing, and Dave will give his talk at 8 o'clock. So if any of you want to volunteer for that, I'd appreciate it. Thank you.
Thanks, Ken. Anything from the schools program, Sid?
None at this time, but hopefully we will get some news next month.
Get some bookings?
It's too early
Yeah.
in the season.
Nelson couldn't be with us this evening and said there wasn't anything particular to bring from National, that couldn't wait until next week. Chris, our Vice President, National Vice President, can say a few words.
Just quickly, we had a very successful General Assembly in Ottawa at the end of June. And now we have Colin Haig as our new president. He's been waiting patiently, and maybe somebody else has been waiting patiently, might be president soon. And our next GA is going to be in Calgary around the July 1st weekend next year. So it's a little closer than Ottawa, and we've got. We were there for the 150th birthday, which was a day of particularly awful weather. So anyway, I'll leave it there.
Chris, is there a president elected every year now for national?
Well, we're kind of in the new territory with the board, and traditionally they've kind of gone for 2 years, and Craig, who was president last year, decided only to do 1 year, and Colin has kind of indicated that he's only going to do 1 year.
Okay.
So, and I may only do 1 year, but we'll see. First, I got to get there. So.
Great, thanks, Chris. Technical committee, Matt, big news.
No, not for sure. Unlike in previous meetings where I've said, maintenance and this and that, we actually have something exciting and new. I have a new roommate. It's a very big box, fit in Dan's new truck quite nicely. And we're going to be taking it to Astro Cafe on next Monday, so please do come there, bring your checkbook. Joe will be doing fundraising.
Not required, but nice.
We will then be taking it up to the VCO, and the tech committee is going to meet and schedule a time to do some new installation. So it's exciting times. Looking forward to seeing first light.
Mm-hmm.
Okay. Anything to oh, okay. Yes. You can have a round. Anything to report from the website, Joe?
No, it's running well. On the fundraising front, I'll just say we just have a few $100s to go to meet our target. But all donations gratefully received for the Victoria Center's upgrade their observatory. So our target was $5,000, and we're more or less there. So a couple more checks and we're done.
Great. Well, thank you for taking that on. And
yeah, it's been great. Just to relate to everybody who wants to get behind the project, and also it's relieved some pressure on the center's budget, because we have an infusion of cash, which is sort of an unexpected time, but unplanned time. And we've more than covered the cost of the project so far.
And maybe to explain that people may not know that the telescope that we were eyeing suddenly came on sale this summer. So it was too good a deal to miss it 20% off. Thus the decision to get it now when.
And we got a hell of a deal on
yes.
the import duties as well.
Yes.
And the exchange rate.
It kind of came together. So it just, the time, we just couldn't really miss this opportunity. So we were planning to do this. But maybe the fundraising might have come a little bit earlier in the process, but it's come on alongside, so it's working out anyway. So thank you to everybody for taking care of that. Michelle isn't here tonight, so I don't know if we have anything else to say about observing, except I have a few announcements or upcoming events. Just a reminder, it's the Island Star Party this weekend, Bright Angel Park in Cowicton. We have our VCO evenings are on Fridays at the moment. But the summer star parties at the DAO are winding down, so I believe we're switching back to Saturdays for October. We have Astro Cafe as mentioned, it's resumed, and we have the first one this week, and it will be going now until the end of May, I guess, with maybe a few exceptions. And we are in temporary accommodations, so if you haven't been, we're in the main building that's on Fairfield Road until our portable is renovated. We're going to try and get the UVic Observatory back going again this year, and that would be on the second Friday of the month. So we're hoping for our first night in October. And Michelle has arranged for us to have the plastic telescope a week, Friday and Saturday, for active observers. That is, again, and some of those things are, of course, weather permitting. I haven't heard from Bruce yet if he wants to try and do Rascals of Cattle Point this year. We haven't had a lot of luck in the past, I think, at least 2 years, but we may try and get that going again and have some open houses at the Dark Sky Park. And the final point, we do have our complimentary copies of Sky News Magazine if you're not a RASC member. We do have, this is the current edition, feel free to take a copy with you. And we'll have those, I'll try and remember to bring them to Astro Cafe as well. So I think that's it on the, did I miss anything? No. So,
Chris?
yes. Oh, sorry, yes, I did miss something, didn't I?
A couple of things.
Yes.
It's that time of year, in that the observing calendars or our RASC calendars are coming up. And so I am putting in an order for calendars. I don't have to pay me now. You can pay me later. I know where you live. I'll come get you. But if you'd like to put down for a calendar, please just give me an email. Maybe I can just pass this around, starting maybe down here, and then it just can kind of wind itself around for the rest of the time. The only other thing is I do want to say for the people who have come out for 18 Saturdays up at the center of the universe, up at the DAO for summer star parties. We had 20 arranged this year. We've got 2 more to go. But for 18 Saturdays, we have had some of the best people come up in order to give our public the benefit of their knowledge and their technical skills. And we really, really appreciate it. It's absolutely marvelous. David Lee has done a fabulous job, bar none, of getting all of the speakers which means sometimes even 2 or even 3 on a night that we've had some people. And he's done a fantastic job. And we want to thank you, David. You've gone way above and beyond. So we have 2 more nights to go. This coming Saturday night and the 23rd. And David is going to be putting on at 7:15 on Saturday night the beginning part of the Nova.
This is Knowledge Network.
Knowledge Network.
So Knowledge Network has just sent me the trailer for Space Suite 3. So I think they're going to start broadcasting this soon.
It already is.
Is it already broadcasting?
I've already seen
Okay, so I have the trailer for it. So unfortunately, we couldn't show it before.
Right, so we're going to start on Saturday. We're going to actually have people coming up and starting at 7:15. I mean, it's also darker, earlier, things can get going a little bit. So if you are one of those wonderful, fabulous people that come up and put telescopes up, it is completely sold out and with waiting lists like you wouldn't believe for the next 2 weeks. So we will need to have people up there. You were just saying it's going to rain on Saturday night, is that what you just told me?
I'm not aware of that. There's several here.
There's several that are so hopefully we will be able to open up. But just to let you know that we will be having people starting a little bit earlier. So if you do set up your telescopes, you might want to come up just that much earlier to have things ready to go. So that will be that. Well, I mean, if we're you can. It'll be 6:45, 6:30.
There's usually somebody at the gate by 6:30.
Actually, there's somebody usually there's a gate at about 6 to 6:15. So you can always.
6:30 is pretty safe.
Yeah, 6:30 is pretty safe. Okay?
Yeah, thank you.
Thank you, yeah.
I was just going to say, and the one thing about doing the bulk order of the calendars, not only can we get a bit of a center discount, the shipping charges are usually quite high too. So if you buy it from Toronto, you're going to pay $17.95 tax and shipping, and we can probably get it to you for $50. We hope.
$15. I mean, you get at least $10 off the
Whatever it
cost,
costs,
the
yeah.
cost of what you would do. So, Christmas presents, you know.
They are beautiful calendars.
They are lovely.
Hey, Reg, we'll just switch back our computers here.
Our talk tonight is about that object that got in the way of the sun a couple of weeks ago and generated a lot of interest. Ted Stroman is a longtime member of RASC in Vancouver, and his day job is with WorkSafe PC, but his passion is the moon, and he has been running for years a very active outreach program, particularly to keep the memory of the Apollo space program alive with young people who are not really that as familiar with it as some of us are. I know that I was coming of age when that project came along, and that was, say, around 1968, something like that. We're coming up to the 50th anniversary of this event, and I was trying to think of what new people who are coming into the field, how they put that perspective. So 1968, if you subtract 50 years from that, it's 1918. So a person in 1968 would be looking back at when the plastic telescope got first light, and also at the end of the World War I. So this is a remote experience for many. So it's really good that people like Ted are keeping the dream alive. But he's also got a lot of interest and information about the formation and geology of the moon. And he has also brought an assistant tonight who I hope you will introduce. So please give me a warm welcome applause from Ted, who came all the way from Vancouver, and I think he's got a good show. Here you go.
Thanks very much, ladies and gentlemen. Indeed, I too joined the crowd as a participant down in Madras in Oregon on the 21st, and my daughter will show you an eclipse live.
What's
Houston, we got a problem.
Yeah.
And they were selling T-shirts at exorbitant prices in town, $20, $25 US. We got them for 10. Everybody can hear me reasonably well? Yeah. Okay.
Get out the duct tape.
Yeah. Okay. Can you open the, which one would you like first? We'll see. All right. Are you hearing me? All right. Yes, all right.
Yeah,
Good.
okay, this is.
All right. As Rick tells us here, yeah, I was one of those young kids. I'm Swedish, and I grew up just in Sweden. And 1969 in July, I was looking up at the half moon and heard Tranquility Base, the eagle has landed. very, very high point, a significant point in my life. Since then, I've been hooked on space astronomy and any kind of space program. Now, as Rex says here, I'm working with the WCB. I'm a health professional, and my hobby is the moon. And so I'm not a planetologist, I'm not a geologist or a chemist, and not even an astronaut, even though some kids are absolutely convinced. But I have studied intensely over the last 5 or 6 years the moon and its creations. I've been basically taking the research as it has come off the hot stove, and there's a lot of research out there. We'll skip over many topics related to that. Unfortunately, I can't give you depth because there's so much stuff. So I'll give you an overview, which will allow you to focus on what you want to learn about on your own, or investigate further. Let's see here. In fact, I have become so popular with some of the kids that they have given me the name the Moon Man. You want to forward it? Okay, just give you a cue. Just push this button. Oh, okay. Yeah. And I was thinking about that during my honeymoon in 2004 with my dear wife. C my nine, just after marriage. We weren't really on the moon. Here's one of the moon products. My daughter Sarah, she's 9 years old, and she really enjoyed her solar eclipse experience. So there's been a lot of theories, of course, of how the moon got there. And in history, of course, going back through our various cultures, the moon has represented the cycle of life, birth and death. And in many religious and cultures, it has actually been both a good symbol, and then I believe the Incas had a very nasty belief about the moon. It had power to come down and suck the blood out of people, and it was a terrible symbol there. The Egyptians had a nicer look at it, I think. And one of the earliest theories may have been something like this, going back to the Stone Age. But on the serious side, the moon is a key to our solar system, a key to how the Earth was formed, because the moon and the Earth are very much related. And read through that yourselves. Those are some of the main points. It's literally a Rosetta Stone that we have next door to Earth, and it's a treasure house. And we're just starting to realize how much we can learn from this little body. All right, this will be on the exam. 4.568 million or billion years ago, the solar system formed. So in scientific terms, they call it giga years to 4.568. At that time, of course, supernova took place, molecules formed into clumps, the clumps grew larger and rotated around our solar disk, finally started forming into protoplanets. And the inner solar system had many protoplanets. They were probably less than the size of a quarter of the moon, but there was lots of them, and they kept colliding. Now, going back again to the beginning. 3 main theories, and I'm sure many of you are familiar with them, dominated the beliefs about how the moon came about. The trick was proving it, if any one was the correct one, and that's kind of tricky if you can't go to the moon and actually look at what's there. I thought, as a kid, the first one, the fusion one, was rather bogus. I think I heard a radio announcement back then about the thought that the moon came out of the Pacific Ocean because the Earth was spinning so fast. And I was picturing in my child's mind a plasticine ball swinging so quickly that suddenly a clump came out, and it didn't make sense to me. And indeed, it doesn't. Doesn't make any sense. How can we prove any of the theory or any future theory about the creation of the moon? Well, we have constraints, real facts that we have to make the theory explain and make sense of. Some of the major things is the angular momentum, and that's how far the moon swings out, comes back, and what kind of angle and orbits it carries out. The lunar mass is a high contention one. As you know, the lunar mass is 1/82nd of the size of the Earth. So it's a very light ping pong ball rolling around a bowling ball in a sense. Something that's come up through the research is that it has a very small core. It's only 1.5 to 2% of the actual body, which is quite small. I believe the Earth is about 40% our core size. So that's why we have this good old gravity and magnetism that protects our atmosphere and so on operating. Another thing that's very important is that a lot of volatiles on the moon are gone or in very small proportions. Theories have to cover that. And also the isotopes in all the rocks and materials on the moon have to be explained in their portions in relation to Earth to explain the qualifying of the theories. Quick little demonstration here. Earth, 9-inch globe. Size comparison, the moon. Put this model, wood globe model myself, put this one together, painted it painstakingly in detail. I'll pass it around shortly and you can have a little look at my artwork. But we can just look at it in terms of its size compared to the Earth's surface. And then of course we know it's at a distance of
389?
384, I think it is, on an average, which lands at about the 7th seat from the end here on an average day. But it swings out a little bit because it's a oval-shaped orbit that swings in a bit on perigee. And oh yeah, I have to say that when people get so excited about the supermoon, right? We hear that PR, the public's interest peaks because they are under the impression that the moon is going to be in here. No, folks. A supermoon means it gets just a little further in by a couple of percent here. And you'll never notice the difference unless you have very fine instruments. So it's a lot of excitement for nothing, I think. We can pass this one along here. What about getting examined this one here? Along the way. Let's keep it upright. Now, of course, we have the great event of the Apollo missions to the moon. They got on the surface there with no less than 6 different crews. They collected some 380 kilos of rock, still being examined to this day and passed around the world. One of the hottest commodities in science. We have lunar laboratories and we have basically a lunar program. You can put in a paper and say, I want to do this with a rock or dust, and your application may be processed, and indeed the lunar sample can be sent to China or Bulgaria or wherever, and they can do a research on it and then present the paper to other scientific international communities, and lots of people have. And on top of that, the Russians, of course, succeeded with their automatic missions. You remember the Luna missions, automatic return missions. However, they got very small chunks of regolite, the lunar soil, along all those ones. So they only collected about 1/3 of a kilo, not an awful lot, but it did add something. And today, something very new. Since the early 1980s, they've been starting to collect lunar meteorites that have landed on the Earth. Lots of them have been found in Antarctica, and now increasingly, as people are becoming more aware and know how and what to look for, they're finding them in the deserts, in Middle East, Australia, and the Sahara are very popular places, and increasing amounts of meteorites are coming in. This is adding to the database and the knowledge base. As you may well be aware, there's about 5 epochs of significance around the moon, and we're talking about the very earliest, starting about 4.5 to 3.9, the pre-Nectarian, the Nectarian age, a very interesting age, and then things start slowing down a bit on the moon in the Imbrian age, and then settle down, and we're technically right now under what is known as the Copernican epoch. Very quiet, moon-wise. So what happened after the Apollo missions? I thought as a kid, wow, well, now they have all these rocks and the scientists done all the work, and so they're going to say, hey, we got the theory, number 1, number 2, number 3, who's the winner? Nothing. There's silence, and everybody's scratching their heads because the data from the rocks didn't match anything of the theories. And everybody was in a conundrum. So there's real silence and head scratching going on in the early 70s, which was really annoying. However, Mr. Williams and William Hartman and Donald Davis happened to meet during a presentation at one of the universities, and they started talking about the moon. They had 2 different approaches, and suddenly as they compared what they had been finding, they were finding that both approaches were actually matching with each other. And then they said, hey, we may have something really good here. So they put out a paper in 1975 suggesting there had been a giant impact scenario creating the moon and the Earth system. And at that time, people said, yeah, okay, that's nice. And it sort of was sidelined for a little while. However, breakthrough, 1984, Kona Conference in Hawaii. All the major bigwigs when it came to lunar research came together. And one of the major agendas was the discussion about the moon. And guess what? They walked out of there with a near full consensus that the impact theory was probably the best answer, and the previous 3 theories were basically tossed in the sidelines. What happened after that was in the 80s and 90s, we had computer simulations. First, they actually started, the computer crunching at that time was pretty minuscule. So they had to go to military defense computers that could crunch a lot of data very quickly. And they started using them. And as they did that, they're starting to say, wow, this really works. We can really make this work. It makes sense. The ballistics and the mixing of materials seem to be working. And as we went through the 80s and 90s, these simulations became more and more sophisticated and could crunch more and more data, and a lot of people got involved. Now, here's a little sideline, but this is significant. Creep. Well, what is that? Well, it's a mix of special rock on the surface of the moon. Potassium, rare earth elements, and phosphorus in a mix. It is present on the Earth, and it can be found in very minuscule amounts around volcanoes. So you will find them around Mauna Kea and places like that. But you have to walk around with a microscope to pick it. The whole moon and a majority of the rocks found on the moon were loaded with this stuff. And again, scientists were saying, what is this and why is it in the rocks? We can't make sense of this. Oh yeah, I was going to say, creep, well, for you ladies, no, it's not one of those guys that meet you in a bar. All right, so what has been found? A number of missions. This is a significant one, of course, is the Clementine, one of the earlier missions. We start figuring out a few things. We found out, for example, that the light surfaces on the moon, the highlands, are about 4.5 to 4.4 billion years old, loaded with what is known as impact bracious and plate clays. Lots of scientific terminology here, but very interestingly, a lot of creep again. The dark stuff is Maria, and these are basalts. Basalts is basically a mineral that's loaded with titanium and iron. They're heavy, lava material. All right, and as we moved along, more and more missions started happening. I was very pleased personally to see that, again, the moon became a subject of interest. We had many missions that have gone out there. Lunar Prospector, Clementine is one of the earlier ones, and then we have Kajuga, Japanese, Smart, Shandy, Chandrana, LRO, L-Cross, Gray, and Laddie. Wow, lots of stuff flying out there and lots of data coming in. And as I mentioned, we're also starting to collect meteorites from Sahara and Antarctica. But, interesting enough, the rocks that are coming from Earth, the surface of the Earth that are recurring, were low on creep. But all the rocks we collected on the moon were high on creep. Well, what's going on here? Well, (1984), coming back to that again. The cataclysm of the collision of a protoplanet called Theia into Earth created the Moon-Earth system. Generally, zinc isotope evidence, we're starting to nail it down. Now we'll see if this computer links here are going to work for us.
You want to get into that?
If we can get into the YouTube, you want to have to help me a little bit here if you can get to it.
So I can't do that. So what I can do is we'll get out of this for now. Which one do you want?
That's the one. Yeah, no, that's the request. Yes. Yeah.
Okay.
You can keep playing that one for me. It's a short one, but it's a good one. Here's one of the earliest computer simulations of the impact between Theia and Earth. And what you want to look out for is the heavy material. We'll come through again here. On the impact, you will see that the heavy material, the core of Theia, actually is torn away and joins the Earth's heavy material in the core, whereas the light stuff from Theia gets tossed out in orbit. You can see it there in that simulation. You can see the heavy materials returning to the center, but you see a lot of stuff out here. This is the stuff that created the moon, the light stuff. Okay. There's one more simulation. Now this is a better one. Shows it very well. It shows also the level of violence you have unleashed. You could only imagine if you're surface of the planet realize that this is it. This is just not a bad earthquake. This is a calamity. Again, you can see all the heavy stuff are in the center. And I'm going to rerun this one again so I can point out a couple of little things here. Look at that clump there, and it's heavy material again getting sucked into the core of the Earth. And if you run it from the beginning there again, Greg, yeah. Now look here, because as it hits, look at that heavy material getting sucked right in there, and the clumps here sticking to the center, and all this material that's out here. That's the moon stuff. Now, you can find a lot more of this on the internet. They have run hundreds, if not thousands of these. Different angles, different weights, different approach, different focus, different material. And they've been playing with this for some 20, 25 years now. Lots of this is going on in supercomputers all over the world. So, going to take you back to inner solar system. Hoping that the sound system will work well now. Inner solar system full of those little planets. One of them, larger planets there, Earth is now about 90% formed, and we're actually, there's some questions as to there might even be the beginning of life on Earth and water forming. However, out of the blue, out of the blue here. Yeah. We might want to take a look at this. I realize here, at this time at the Earth, we were bombarded continuously by these smaller material from these inner solar system. Lots of meteorites, rocks, little protoplanets would join the Earth, and we were being pounded. And then they closed in on us. Lots of those little planets. Back to our regular program. created, and I already demonstrated the distances between today's moons in the Earth system, and now, after creation, they figure, where did my moon go? Is it still out traveling there? Oh, there it is. There we go, just like they are. Yeah. Yeah, sure. So, the Roche limit to the Earth is about there, usually on that side. Right out in that periphery, right here, is where they figured the moon was created. Now, here's an interesting thing. Any guesses here how long it took the moon to coalesce? Thanks. Oops. Any guesses? 200 million years. 200 years? 1,000 years? 20,000 years? A million years? Believe it or not, I've surprised myself. The research points very strongly to that the moon was coalesced in 100 to 200 years. 90% of its size. 100 to 200 years. Bang, boom, there's the moon. Now, after it was formed, of course, can you imagine? It was hot. With that enormous exchange of energy between the two bodies and all the bombardment, a lot of heat was concentrated on the moon. And here we come to a very important concept. It's called the magma ocean concept. Basically, it was a little cauldron boiling like crazy with material. And two types of rocks were being formed out of this. First, we have the heavier rocks, which were the olivine and the pyroxene, and then, significantly, the feldspar. The feldspar is low on iron. It starts going to the top. What kind of analogy can I use? Well, you make yourself a cup of hot chocolate, right? You put peanuts in it and marshmallows. Where do you expect them to go? Well, of course, we're going to have the marshmallows at the top, and that's exactly what happened to the moon. The feldspar, also known as anthracite, start going to the top and coagulated there. Everything starts cooling down with these rocks separated in this way. This is very significant. On the moon, therefore, we find an anthracite, a lot of it. And it's very white or light gray in color. It's very low on iron. However, the creep loaded ilmenite is the darker rock, but it's further down deeper. And there's a couple other types of it too. A good example is the Genesis rock picked up by Apollo 15 in 1970, I believe. It was 95%. 71? Well, there we go, I'm just not correctly. It was 95% anthracite, so it's almost pure surface rock. So the research came on, and with some of the knowledge at the time, they start saying, well, when did the moon get formed? So the theories ranged wildly here between 30 million years after the formation of the solar system up to 140 million years.
She just said, I better come help you out.
Yeah, she's going to get a chance here. Another interesting part here is that as the protoplanets formed, Mercury, Venus, Earth, and Theia, Mars, and so forth, they had, as they believed, a different makeup, a unique mix of material and isotopic ratios. So you can tell, if you take a rock off of Mercury and compare it chemically to that one of Venus or Earth, the Moon, or Mars, they will distinctly have a very clear signature. And this bears out in reality. Just look at this data. Vesta meteorites, if you compare oxygen to, oxygen 17 is one of the isotopes of oxygen, and oxygen 18, another isotope, if you compare them on a scale, and you put Earth on this line here, Then we have all the Mars meteorites coming out here, quite distinctly different. Their oxygen ratios are different. And if you look at the Vesta meteorites, they are different too. But look at the moon. It's right on the line. It's identical to Earth. So what's going on here? How can it be? Now here's a clinch. It became a realization in the 90s that when they ran these dynamic models, these computerized models, my God, at the absolute wrong time, kill that thing. In the late 80s, early 90s, when we started looking at data, the computer models showed very clearly on impact that all the heavy materials and a lot of material would be sucked into the Earth. And 70 or 80% of the light stuff out there should form the moon and be from Theia. However, if Theia had a different isotope signature, a distinctly different one, it would not match Earth. But all the materials that Apollo and Luna samples had brought in did match Earth's isotope ratios very well, almost in the whole spectrum. Many, many isotopes were matching very well. So we were in a crisis. One dynamic model said one thing, and the chemistry said the other thing. So this almost got into fist fights in some of these interplanetary meetings when they were talking about the competing theories. People got quite passionate, almost getting into fights with each other until some solutions were offered. For example, right after the impact, there would have been a disk of very hot plasma, rocks and turbulating rocks. And some scientists were saying, hey, well, in that mix, the isotopes could mix nicely and match up between Earth and Moon. And then they separated and they would still be matching. And that seemed to work. But one problem. Titanium was equally matched between the Moon and Earth. And they were saying it's a refractory metal. What does that mean? It can only exchange isotopes at a very high heat. But the plasma disk could not hold that heat for that long because, as I said, in only 200 years or so, the Moon coalesced. And it wouldn't have been able to keep that heat for that long. So there's no way any of the people who are experts on metals would say that titanium could equilibrate. It would not be able to do that. So what's going on? I can talk for some time here, folks. So basically, the equilibration theory or suggestion was, again, not matching with what we were seeing. Again, there was no agreement, and we had not found the smoking gun here to making this work. Right, now I'm going to take a side step. Right after the lunar surface had cooled down, something started happening. And this is what we call delayed heavy bombardment. It took place about 4 billion to 3.8 gigayears or billion years ago. And the surface of the Moon got pounded. And they know this because the rocks, again, gives the isotope signatures, and zircons of the Moon reads this story. So they have figured out the Imbrium, for example, this big impact was formed at 3.85 billion years. Crisium just a little later, and so on and so on. The last one to hit home was Orientalis on the side. This one gives it at 3.880. There's some authorities that rate it as low as 3.7. Yeah. So, what caused this late heavy bombardment? Well, as one suggestion was a planet V or 5 could have kicked off asteroid pieces that came into the inner solar system and bombarded the inner solar system. Another suggestion was the Nice model. Well, what's the Nice model? It's not the Nice model, it's the Nice model. There's a French research team that came up with this one. They looked at the solar system after formation about at the time when the Moon was being formed, they look at the gravitational interaction with the outer planets. We're looking at the Saturn, Jupiter, Uranus, and Neptune, of course. And this is after creation, and this is at the time when they got into orbital resonance, when Jupiter and Saturn moved out in a certain way that they actually start shaking the entire solar system with the gravity waves. And do you see what's happening here? Look at Neptune, the third outer gas giant, right? And then the fourth. It managed to switch Uranus and Neptune in their orbits according to this. So there's some very powerful forces operating, obviously. On the same time, there's lots of ice meteorites, rocks out there that were being thrown around the solar system, and many of them headed, of course, into the inner solar system, pounding Earth and Moon. The NIST models now is followed by a new model that has come out recently called the Grand TAC model. I encourage you to investigate that one too. It's very interesting stuff. Now, here's the time scale. Creation of the moon system, the solar system at time 0. And here's the moon, the amount of bombardment, of course, right after it was formed, massive, and then dropping off, dropping off, and basically petering out to 0. Now, the late heavy bombardment would have been peaking here. And right there, it would have peaked because of the creation of all these great embryon bases. And this has been heavily debated now. There's another suggestion called the sawtooth-like bombardment, which would only make this look like that. There's lots of discussions about exactly how that took place and when. All right. Now heading down to the lunar surface, we were talking about the anorthosites on the top and the basalts. How did the basalt come into play? Well, when the moon was being pounded, then these ground underneath, of course, was broken and lava poured out on top. They have actually done tests from the Apollo samples where they put a lot of heat on the moon samples, and they melt literally into an oil-like substance, and they run forever. They're not like the lava that we know on Earth. This is totally different. And they run for great distances and covering great amount of ground. And we can actually see the lava flow ends. And if you look at sinus iridium here, of course, you can actually see how one after the other layers of lava have flowed into this and flooded this great basin bit by bit. Was everything on the surface that are embryons or lava plains formed by impact? Well, embryon certainly is quite evident. You can actually see it in the mountains around it. Some people have proposed that the entire Procellarium was formed by an impact as well. However, can anybody see a problem with that? Just at looking at the moon. I see a big chunk of highlands in the middle of the crater. How would they get there if it was an impact? Would they be flattened out and gone? So the theory was questioned by a number of authorities. And indeed, once we start getting some very detailed data from the surface of the moon, for example here, from the lunar prospector, we start seeing that there's something very special going on Procellarium. Thorium is very much connected with the creep material, which comes from very deep in the moon. But if you look at the rest of the moon, there is no creep around here. Very little of it. It's a little bit on the backside here. But largely, there's no other creep pour-outs anywhere else. We came to the Grail mission. Again, another scientific breakthrough. When they start looking at the magnetic signature of the moon, they start seeing some interesting patterns. Definitely we had impacts here. Bang, 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 number of hits. But there's no big real impact here where the Prosolarium is there? However, if we look at the wrinkle ridges and the scarps and the magnetic signatures, see what's going on here? There's cracks that line in almost a square pattern around the moon. So what they have figured is, as the moon cooled after all these bombardments and break-ins, the mares shrank and the edges cracked, pouring on more magma from deep within the earth. The thorium and the creep crept up and literally filled Mare Prosolarium. No impact, but we're talking a subsurface phenomenon unrelated to impact. And maybe it looked like that about 4 billion years ago. Great big edges pouring out magma, filling in these Mare bases. And surprises again. Latest research from the LRO, they have been able to really focus in on some areas. They have found lava, active new material on a much smaller scale, and these have been figured out to be less than or around 50 to 100 million years old. In other words, fairly recent. We thought the moon was dead. Perhaps it's not quite dead. All right. The LRO have also found out some very interesting stuff here. This is the backside of the moon. Lots of interesting stuff to be found here. For example, we have the Aitken subpolar basin, largest impact in the solar system ever recorded. It has a depth of some 13 kilometers. In other words, we could stick 2 Mount Everest on top of each other, have room to spare. That's pretty deep. They're suspecting lunar ice, perhaps on the South Pole in particular. Now they have also found on the north part of the backside of the moon a silicate volcano, not the other type I was telling you about. So here again, another phenomenon that can't be explained, a mystery to be found out. Interesting side note here. When this great impact took place, where do you think it came from? What angle did it impact? If you just look at that picture and the data, any suggestions? Seems quite logical to me that the impact came from here, throwing materials out over here. It came from the bottom and up. And thus, we have the largest, tallest mountains on the moon on the backside, just north of that basin.
Is that why the backside of the Earth, or backside of the moon is thicker than the
That could
backside?
be certainly part of that, yes. Yeah, absolutely, good observation. Now, another side step here. February 2013, you remember the hit in Russia, right? You all saw that in the news and watched it. Lucky that they didn't get any casualties, serious casualties from that. Well, it was just an ordinary Klondike meteorite containing about 10% iron. Is that sensational? Well, not evident right then. A little earlier, about a year earlier, another meteorite had struck North California. When they did the isotope checks on them, they came out at 4.472 billion years old, and the Russian impact at very close values, both of these. They came about the same time, same ballistics, and what's significant is this. Why is this in 2 parts? This is chondrite, and this is asteroid. The timing of this matches very well with the time frame of the creation of the Earth and the Moon. Material would have been flung out of the Earth-Moon system into the asteroid belt and impacting it and locking the time clock. We're getting feedback from 4.4 billion years ago through that comet. Quite sensational. Now, coming back to the isotope crisis, it didn't match the dynamics. However, just a couple of years ago, a young lady, and I'm not going to bothered to pronounce his name, but a very bright team operating also with a French team. They started crunching again supercomputer, and they found that indeed they could make the whole isotope thing come to rest, because the Theia body would almost be identical to the Earth one. So that would explain the very close matches, thus taking away the dilemma or the crisis. So toward the end here now, very interesting, lots of research about coming in on all these meteorites that are landing in the desert and in Antarctica. Here's a sample here from Northwest Africa. Lots of stuff are coming in from Oman. They did a study where this team was really smart. They took all of the meteorites and they did their chemical signature, and then they fed them back into the moon map. And lo and behold, many of them did not come from the Mare regions. They came from the other regions. And if you know your geology of the moon, only 16% of the total surface of the moon is the Mares. And where did they land all the moon missions and the Luna missions? Well, they landed them in the Mare. They were picking creep stuff out, thinking that creep is everywhere on the moon, but they were in a unique place. Less than 16% of the surface was this area where they're picking stuff. So now we're getting a more equal picture. We're getting materials that have been randomly kicked off the moon through millions of years, and they're rebuilding the moon map and saying there's a distinct region with creep from Procellarium, and then there's two types of lunar highland material and a different material in the south, on the backside in the impact area of Atkinson. My dedication to my hero. There's one more good video that sums up the last, the sequence right after the lunar. This one here. Yeah. That's very nice. Sums up the whole evolution of the moon, late heavy bombardment, followed by the lava flows on the moon, and the moon settling down. From our favorite spaceship, the LRO. Taking you back right after the impact. A very hot, boiling Earth. So as we mentioned before, I run the first moon landing program. One of my major props is the Saturn V Giant. Compared to a regular family of 3 or 4 with a good old Volvo car. How did that happen? That's the scale, folks. It's a monster, 365 feet tall, 110.6 meters, roaring into the sky with over 6 million foot-pounds, 7, correction, 7.5, I think it was, yeah. Foot-pounds of thrust, putting 6 crews on the surface of the moon. I'm opening up every table for a discussion, comments, questions, intrigue.
Well, thanks very much, Ted. That was a great talk, and you certainly filled in. There's a lot of gaps in my knowledge of the moon. I learned an awful lot tonight myself, and I really appreciate it. I've got one question that started off. When I look out there and I see all of the Maria on this side of the Earth, do you think the proximity to the Earth might have pulled the stronger gravitational force on that side, might have drawn the lava out in that area, or is it?
Well, there's a number of different thoughts, and again, there's a number of different theories and proposals that come in. There is even a theory that we actually may be looking at the backside of the moon because it has been turned around from an impact that was created when the backside was the front side and getting those heavy impacts from the outside, and then the last one spinning the moon around and locking. That's one theory. I'm not totally convinced. There's some inner parts, for example, the core of the center of the moon is moved in about 2 kilometers or so toward the Earth. So the moon is lopsided. We have much more mass on the back side and a little more thinning on the front side. Also, the surface on the front side is around the latest data points that it's about 45 kilometers in thickness in the surface layer. Whereas the thickness on the backside is around 55 or 60 kilometers on the backside. Why is this? Well, yeah, it's ongoing research and new missions and more data and so on will provide more clarity on that in due course. So perhaps not is my answer.
Any other questions? Chris?
Yeah, thanks for a most interesting presentation. I was wondering about where the Oriental Basin fits into all this. I'd be surprised not to see any reference to it.
Yeah, no, I did mention it was the last impact that came in on the moon, and it was indeed on the side, and we hardly ever see it. Of course, the astronauts have the perfect view, and all the automatic missions can see it and have mapped it out in detail. It was one of the last impacts that formed the basin. So yeah. Why do we know that? Because there was less flooding in it, and what do you call it? The geology of it is much rougher as well. That points to it being a lake impact.
Any other questions? John?
Yes, the issue of the planetary orbit dynamics. I remember reading a while back, and I don't know how current the information is, that some of the models predict that we will get into future instabilities as the resonances alter.
Yeah.
Do you know anything about that?
Yeah, definitely. What will happen is our fabulous solar eclipses that we enjoyed just last month will become less and less in frequency as the moon is actually moving further away. They have measured this with the laser beams since they put them on the surface of the moon. We're on an average going out about 38 millimeters per year. The moon is receding, and in about 600 years or so, we won't have any eclipses, 600 million years, we won't have any solar eclipses taking place because the moon will never be able to cover the entire sun. Further to that, yes, there's a resonance between the Earth and Moon. So the Moon is indeed in lock with us. It has a tidal lock because of our tides that slow down the Moon's own rotation. So now the face of the Moon is always pointing toward us as it goes around in orbit. Slowly, our own day is also receding. We're losing, I think they calculated 1 second per 20,000 years or something like that is data. So the dinosaurs, when they were moving around the Earth, they had a 23-hour day. We are having a 24-hour day, and I can't remember how many millions of years we'll have a 25-hour day, and I would appreciate that because I need a lot more sleeping time. So, anybody else?
Well, thanks very much, Ted, and to your assistants as well. As a token of our appreciation, we have a coveted water bottle, and I will take a look at it. Yeah. So I do appreciate Ted coming over. A fund from the RASC has helped to raise some of his travel costs, but he's generously given his time preparing this, and also time to come over here. So thanks again very much for coming. We really enjoyed it.